Hello everybody and welcome to IP Video Surveillance for Concentrated Seller and Installer course. My name is Abdurrahim Ashraq and I'm gonna be your teacher on this course. So before starting, I would like to assure you that the course is 100% useful information. So my recommendation is when you are watching this course, please open a notepad or text file or open any similar thing on your device just to take notes for anything that is very important. And the reason for this is that we learn really faster if we are writing things as well as just looking at them. So the main action to take note is gonna help you get in your head these important points. Alright, let's move on and see you in the next lecture. Let's start by the surveillance purpose. So the IP surveillance system, as you know, display, record, and retrieve video imagery, audio, and other information in order to observe area of interest, investigate incidents, and also export evidence. So what are the components for the system made us doing all this stuff? Let's see that in the next lecture. Welcome back everybody again. And now we are going to start going through the system. So let's take a look about the software as first component of video surveillance system. So the software element is called the video management software or VMS. So the VMS allow you to view in live multiple cameras, record and retrieve video, and also monitor alarms. And there are two types of VMS. VMS from the camera constructor as the first type. For example, BVMS at Bosch. So Bosch brand are doing the camera and they have their own VMS called BVMS. And also Axis brand, they do the camera and they have their own VMS called Axis Companion. And the same thing in Hikvision brand. Their free VMS is called IVMS 4200 or others. And we have also VMS worldwide leader such as Milestone, Genetec, AccentSoft, Emitis, and others. So the VMS from the camera constructor have full integration just with their own camera. In some cases, some VMS integrate other camera constructor using on-vive profile S. So always, if you want to integrate another different on-vive camera with different brand than the VMS already used, please check if the VMS support on-vive profile S. And this integration is not full. They cannot utilize and exploit all the features of the camera. So you will ask yourself what on-vive profile S is. So to communicate how IP-based video surveillance products from different manufacturers are compatible with each other, on-vive profile S cover basic video streaming functionality, enabling the VMS to configure and request video streams from IP camera or video encoder. So you are not locked in a single brand and you can install different brand camera and have a screen video from the VMS of all different brands. Just make sure that the VMS and the cameras are compatible on Vive Profile S. I repeat, on Vive Profile S covers just the basic stream functionality. And for the VMS worldwide leader, they support a very large number of camera manufacturers, including the camera on Vive Profile S. And the integration is full. That means you can integrate all the features of camera, video, analytic data, and others. And also allow you to create custom surveillance solution for specific industry needs, such as combining video with access control or maybe linking video with transaction data and other cases. But please always verify by yourself the integration between the VMS used and the camera. For the majority of VMS, they have an online list of the integration camera approved by CHEST. We can do a quick example here to know if the camera is complete with the VMS or not. For example, we check Milestone X Protect. This VMS is integrated to more than 100 different devices manufactured and also over than 6,000 devices. It's number 1 in 2016. To verify the compatibility of the camera with Milestone VMS, first enter to www.milestone.com. Choose Solution and click on Supported Device. Now you choose which platform or X project Milestone you are using. For example, for the big project, we're gonna choose Corporate. You click to show device, and now you can filter your device by choosing the manufacturer or device type or others. Let's take an example with AKS manufacturer. As you can see here, all the compatible camera device with corporate, we have 4 page with 100 device each. Or simply you can just enter the part number of the camera and click on it. You can print if you want. And here you can see all the features of the camera compatible and supported by the VMS. We will talk about the hardware systems and components in the next lecture. So, to display, store, and export surveillance data, IP surveillance systems rely on several different components and subsystems, including camera and other devices. Those devices typically include microphone, input-output, sensors, and others. Also, we have network components and protocol, storage devices, servers, and client. First component, as we just see, is the cameras. This device receives the information and digitally encoded to video, audio, and other information. It depends, of course, of the type of camera, because some camera have analytics and then transmit that information over an Ethernet IP network where it can be stored, copied, and added to the database. Next, network. So IP surveillance systems use standard IT network components to transmit data. So I will not talk about the basics of networking because normally it is too easy and I will not waste your time. For the beginners, you can search just for switch role and the first 2 layers from OSI model, and that's it. Next component is the storage. So the video surveillance system needs a storage system consisting of 1 or more disks to store the recorded surveillance data. That means video, audio, and analytics data. Of course, aside from the disk system required by the operation system to run. And this storage system may consist of only disks inside the PC or the server running the VMS. Or you may supplement the internal disk system with an external system as a way to increase the time video is retained. External storage may be network attached storage, NAS, or storage area network, SAN, which provides increased storage space and more reliable and redundant storage option. Don't worry, we'll see the detail of those storage type in this course. Next, the server. So the server is a PC, whether desktop or several physical form factor that runs the VMS. And the specification of the servers depend on the system design. That means you have to have the server requirement depending of your surveillance system. That means number of camera, resolution, compression, and others. Don't worry, we'll see that in this course. And most often the server also contains the storage system that is used to store surveillance video. And the last thing is the software client. It is designed to be run remotely on the operator's computer and support multi-screen use in full screen mode or as floating windows where the windows can be resized and moved freely. Please pay attention here. In the majority of brand or camera constructor, you can find a hardware called NVR. Network Video Recorder. So NVR is a really complete recording system that includes all computer or server, storage, and the VMS software. Also, they can include a graphic card for displaying video, that means the clients. And also for some brand you can find the NVR with network port to connect the network camera. So these NVR products are based on Windows or Linux, easy to install and easy to use. Please don't hesitate to ask questions if you have any remarks, and let's move on the next lesson. Welcome back everybody. So in order to determine the appropriate devices for a given surveillance situation, you must consider the surveillance objective. Depending on the situation, you will want to have specific levels of image quality, which usually include these following: detection, observation, recognition, and identification. So the traditional way of defining those requirements for analog CCTV system was to specify the height of the observed object as a percentage of the vertical image, and different surveillance objectives required different percentages. For example, detecting the presence of the person in a scene might require that the height of the person occupies 20% of the view, and a recognition person, however, might require that the person occupies 40%, and identification person might require 140% or more. And that's the old way for the analog camera, but now network video camera today offer a much wider range of resolution, and using the percentage required from the analog world is no longer practical. Instead, we now use pixel when specifying resolution requirements, and that's what we called DORI. Alright, we'll continue the explanation of DORI in the next lecture. Hello guys again. The DORI distance is a distance which makes it easy to pinpoint the right camera for your needs. When we say the right camera, we mean the right focal length or field of view and the right resolution, depending on the distance to the object to respond to specific requirements such as detection or observation, recognition, or identification. So the DORI defines also the number of pixels per meter to detect, observe, recognize, and identify respectively. So as you can see, the standard EN15132 here shows exactly how much of pixel per meter needed for specific requirement. For detection requirement, the minimum image quality is 25 pixels per meter. As you can see from the image here, the quality is not sufficient to see detailed behavior of smaller objects. Also, it is impossible to recognize any personal feature of the individual in the image. And for the observation requirement, the minimum image is 63 pixels per meter. As you can see from the image here, it is impossible to view the behavior of individuals, but neither recognition or identification of person is possible. Recognition requires an image in which a person is identifiable by someone familiar with the person, but not necessarily by someone unfamiliar with that individual. And the minimum image quality for identification is 250 pixels per meter. Identification requires an image in which person is safely identifiable by someone unfamiliar with that individual. Personal details like glasses, jewelry, or tattoos are usually identifiable. Don't worry guys if it seems difficult to understand that. We'll see an example using a simple powerful tools to define and detect exactly the focal length needed with the resolution depending on the distance between the camera and the area in which you want to control. Controlling means detect, observe, recognize, or identify the person. Let's move now to the example. Our objective in this example is to capture in full figure each person entered to the shop. So the image quality had to be higher enough for identification. Let me show you how to find the resolution and field of view of this camera to identify persons. First, we need to find the exact distance to the object. As you can see from the example here, distance from the camera to the subject or person is not the same as the distance from the person to a spot below in blue. For that reason, in many cases you must also account for height of the camera to determine the true distance from the camera to the subject. It is better to do that using Pythagorean theorem. For example, if the distance from ceiling mount camera is 6 meters, A, and the height of the camera is 3 meters, B, this gives us the result of 6.7 meters, which is the correct distance from the camera to the subject. A more practical method of determining the distance is to use laser rangefinder. Rangefinders are small, inexpensive, and can eliminate error when calculating or estimating distance. So now, after calculating the distance between the camera and the subject, we need now to find the right image quality. To identify person as we see on the preceding lesson, we need 250 ppm. If you don't understand what does it mean, please get back to the previous story lesson. So now we go to www.ipvm.com. It's very powerful tool. Click on tools and choose calculator. Click on add camera. We're using now a generic camera, but you can enter and select your module if you want by clicking on select module. Anyway, now as you can see here we have different variables. So we start by the cheapest cost choices for the camera. So we're gonna start by minimum of acceptable resolution those days is 1 megapixel. We fix the distance calculated previously is 6.7 meters. And now we are going to choose different value of focal length until having a minimum of 250 ppm. And in the same time, see if the weight distance is tolerated or not. As you can see, 5 mm is perfect and the weight is 6.4 meter, which is tolerated for an entry shop. And this is how you will see the face picture. Please don't worry if you didn't understand the resolution, focal length and the other variable, because we'll see that step by step in this course. So my recommendation is to go through the entire course one time and go back to the beginning and start implementing the lessons after you've completely been through the whole course one time. Once again, don't forget to ask questions and see you in the next lecture. Hello everybody again. Let's move now to just a quick review about the camera component. So the camera in general is similar to the human eyes. As you can see here, the important component of the camera that you have to know are lens, iris, and the sensor. So the lens is a glasses or transparent plastic and it's generally focused near or far from the object. For the iris, it's control the lens opening to control the amount of incoming light. The sensor filters the color frequencies and transmits this into electronic signal. Alright, this is just a quick review about the important component of the camera that you have to know, and let's move to the next lecture. Light sensitivity or minimum illumination refer to the smallest amount of light needed for the camera to produce an image of usable quality. Minimum illumination is presented in lux, which is the measure of illuminance. In general, provided it is not overexposed, the image will be better the more light that is available in the scene. If the amount of light is insufficient, the image will be noisy or dark. The amount of light that is required to produce a good quality image depends on the camera and how sensitive to light it is. Many manufacturers specify the minimum level of illuminance needed for a network camera to produce an acceptable image. A similar comparison between products from different manufacturers is flawed by default. This is because different manufacturers use different methods and have different criteria for what is an acceptable image. In other words, the process of measuring light sensitivity is complicated, and to be honest with you, there are several reasons for this. Let's move now to the color measurement. Different light conditions offer different illuminance. Many natural scenes have fairly complex illumination, with both shadow and highlight, that give different lux reading in different parts of a scene. It is important, therefore, to keep in mind that one lux reading does not indicate that the light condition for a scene as a whole. Alright, thanks for watching and see you in the next lecture. Most crime happen during night or in dark environments, but with good illumination in combination with security camera, it's easier to recognize details during criminal activities. To capture good quality image in low light or dark conditions, a day and night camera that takes advantage of near-infrared light is required. For detection in complete darkness and difficult conditions such as smoke, haze, and dust, you can use the infrared light for white light or thermal network camera that provide the best solution, but is still more expensive than the visible camera. Just an advice, the world leader in LED lighting for security and safety is Ritek. You have to know that infrared projector for Bosch or Axis brand are made by Ritek. So if you want to optimize your solution, especially for the biggest projects, you can go directly to the source. So for that, there are multiple possibilities to ensure good quality of video using light detector or infrared illumination. You have to know that any image or video will contain a certain amount of noise. Noise means pixel values that are not correct representations of the scene, and that negatively impacts the viewing experience, aesthetically or practically. The noise is picked up from a variety of sources, including the image sensor and the other electronic components of the camera, but also from the light itself. So as you can see from the example here, infrared here reduce the noise in the image, which will lead to lower bandwidth. Lower bandwidth mean saving storage costs and reducing network strain. Alright, see you in the next lecture. Let's move now to field of view. This is the most important consideration to take into account when selecting your camera. So field of view is measured by millimeter, and it's defining how much of scene and level of detail are to be captured by the camera. That means the area of coverage and the degree of detail to be viewed. So the field of view is determined by focal length of the lens and the size of the image sensor. Both are specified in the network camera's datasheet. A lens focal length is defined as the distance between the lens and the sensor of the camera. So you can change the angle of view and the field of view by changing the focal length by moving lens closer or farther from the image sensor of the camera. So the short focal length mean wide angle of view and the long focal length mean tele angle of view. To calculate the field of view, you have to use a mathematical formula or software calculator. I suggest personally to use powerful tools IPVM, and there are too many other tools like Axis Calculator Lens and others. So please, if you don't know how to calculate the field of view using IPVM, get back to the previous Dory lesson. Thank you for watching and see you in a minute. Iris opening plays an important role to image quality. An iris is used to maintain the optimum light level to the image sensor, so that image can be sharp, clear, and correctly exposed with good contrast and good resolution. The iris can also be used to control the depth of field. We'll see the depth of field in the next lesson. So why we do need the iris control on the camera? First of all, to not have too bright image or too dark image, and also to control the depth of field. And there are multiple iris control type. We have fixed iris, manual iris, DC iris, and video iris. Let's move now to the type of iris lens. So the fixed iris used in indoor environment where the light level may be constant. So with the fixed iris lens, the iris opening is fixed at a certain f number and cannot be adjusted. So this type is used in the scene with the same light level. The fixed iris type is too much cheaper than the other type. And for the manual iris, have a manual iris lenses. So the iris can be adjusted by turning a ring on the lens to open or close the iris. This is not convenient in environment with changing light condition, such as outdoor surveillance application. And for the other two type of iris lenses, we call them auto iris. And we have two type of auto iris. First type is DC iris and the second type is video iris. Both have a motor-driven, automatically adjustable iris opening that responds to changes in light level. And also both use an analog signal to control the iris opening. So the difference between the two is where the circuitry to convert the analog signal into motor control signal is located. In the DC iris lenses, the circuit resides inside the camera, but for the video iris, it is inside the lenses. Don't worry guys, we will see in the next slide the difference between those two types of iris. As you can see here, the circuit at the DC iris lens that control the iris opening resides inside the camera. And for the video iris, the circuit that control the iris opening, it is inside the lens. Okay, let's move to the next lecture. Depth of field refers to the distance in front of and beyond the point of focus, where objects appear to be sharp simultaneously. Depth of field may be important, for instance, in monitoring parking lot, where there may be a need to identify license plates of cars. Depth of field is affected by three factors: focal length, iris diameter, and the distance of the camera to the subject. So let's see the examples in the next slide. As you can see from this example, depth of field is based on the iris opening value, that means the f number or f-stop. This value specifies the range of incoming light and creates the depth of field. So the highest value of f-stop lens open is minimum, and the lowest value of f-stop lens opening is maximum. So the f-stop numbers are always given by the following set numbers. Most used is 1, 1.4, 2, 2.8, and others. Imagine a line of cars behind each other. So as you can see, a large f number, 5.6 in our example, that means smaller iris opening, enable object to be in focus over a long range. So we can identify the plate of all in front and behind the midpoint. Let's move now to the type of lenses. We have three types: fixed, varifocal, and zoom lenses. The fixed lens offer a focal length that is fixed and only have one field of view, either normal, telephoto, or wide angle. The varifocal lens offer a range of focal lengths and hence different field of view, but the field of view can be just manually adjusted. So whenever the field of view is changed, the user has to manually refocus the lens. And the zoom lenses are like focal lenses, so they enable the user to select different field of view. However, with zoom lens, there is no need to refocus the lens if the field of view is changed. Focus can be maintained within a range of focal lengths. For example, 6 to 48 mm. Lens adjustments can be either manual or motorized from the remote control. Let's move now guys to the first exercise. So we want to cover the parking lot in one image during the day and the night. We have some additional information here. This is an industrial environment and the height of installation is 5 meters and the parking lot distance is 10 meters. The width of the parking lot is 40 meters and this is very busy during the daytime. That means we have more of scenery and we have no additional light during nighttime. So what is the correct answer? We can choose multiple choices. We have A, fixed lens with fixed iris control, B, manual lens with manual iris control, or C, zoom lens with DC iris control, or D, varifocal lens with DC iris control. So the correct answer are C and D, zoom lens with DC iris control and varifocal lens with DC iris control. Because for outdoor it is very important to control the iris continuously because of the various of incoming light. So the DC iris control ensure that the iris always opened as good as possible to ensure there is not too much light incoming to the sensor, but also during least light the iris is controlled to be more opened as during the day. And for A and B are wrong because fixed and manual iris control are not very useful in an outdoor application because of variable light intensity during day and night. Hello back again. Let's move now to the second exercise. So we want to see an overview of the restaurant at the second floor. The cameras should be installed above the entrance to view the guests in the restaurant, and the camera will be used during day and night, but as live only. Some additional information: this is a restaurant environment. The height of the camera is 3 meters and the width of the restaurant is 8 meters. We have more of scenery and we have some light during night. So what is the recommended answers? We can choose multiple choices. A. Fixed lens with fixed iris control. B. Manual lens with manual iris control. Or C. Zoom lens with DC iris control. Or D. Varifocal lens with DC iris control. Correct answer here are all choices A, B, C, and D, but I highly recommend A because it's more cheaper than the other choices. So since there is some light during night and this camera is only being used to get an overview, most likely other cameras will secure area like the entrance. The restaurant is also on the second floor, so the windows are least important to secure. However, when used fixed or manual iris, the installer have to ensure that the visible light is always correct according to the iris opening, as well during night as the day. Let's move now to the exercise 3. So the operator does require to have an overview of the entrance. There is a lot of movement during day and reflection during night because of the amount of light. Some additional information: the height of the camera is 3 meters. The entrance area of an airport with only windows around. This is very busy during daytime, that means scenery, and some light during night. So what is the recommended choices? We have fixed lens with fixed iris control, manual lens with manual iris control, zoom lens with DC iris control, or varifocal lens with DC iris control. So the good answers are C and D, zoom lens with DC iris control, or D, varifocal lens with DC iris control. Because of the light and the amount of windows in the scene, a lot of reflection will take places. With DC iris lens, the camera will automatically adjust the iris opening, which will prevent overexposure. And for B and A are wrong, because fixed and manual lens cannot adjust the iris opening, which will overexpose the image with the daylight, or the image will be too dark during low light. Let's move now to the lens mount. When changing a lens, it is also important to know what type of lens mount the network body camera has. So there are two main standards used on the network camera: CS mount and C mount. The difference between the both is the distance between the lens and the sensor. It's 12.5 mm for the CS mount and 17.526 mm for the C mount. Please guys, pay attention here. You know what happens when using C mount lens at CS mount camera body? So the sensor will be damaged and you have to send the camera for repair request to the manufacturer. And of course, the warranty might be refused. Let's move now to the sensor definition. As you know, the camera operates when direct or reflected light enters the camera. So as the light passes through a lens, it is focused on the camera's image sensor. An image sensor is made up of many photosites, and each photosite corresponds to a picture element, more commonly known as pixel. Each pixel on image sensor registers the amount of light it is exposed to and converts it into a corresponding number of electrons. The brighter light, the more electrons are generated. So when building a camera, there are two main technologies that can be used for the camera's image sensor: CCD and CMOS. So what's the difference between the both? CCD sensors have been used in camera for more than 30 years and present many advantageous qualities. Generally, they still offer slightly better light sensitivity and produce less noise than CMOS sensor. higher light sensitivity translated to better image in low light condition, however, are more expensive and more complex to incorporate into a camera. A CCD can also consume as much as 100 times more power than equivalent CMOS sensor. And for CMOS technology, recent advances bring them closer to their CCD counterpart in terms of image quality. CMOS sensors lower the total cost for the camera since they contain all the logics needed to build camera around them. In comparison with CCDs, CMOS sensors enable more integration possibilities and more functions, and it is faster readout, which is advantageous when high-resolution images are required. So the megapixel CMOS sensors are more widely available, are less expensive than megapixel CCD sensors. So megapixel CMOS sensors are more widely available and are less expensive than megapixel CCD sensors. Sensor sizes are expressed in inches notation. As you can see here, there are different sizes of sensor in the market, 1 inches or 1 divided by 2 inches and others. You have to pay attention here. This is very important when you are choosing the box camera and the lens separately. If the lens is made for smaller image sensor than the one that is actually fitted inside the camera, the image will have black corner. See the left hand illustration below. If a lens is made for a larger image sensor than the one that is actually fitted inside the camera, the field of view will be smaller than the lens capability, since part of the information will be lost outside the image sensor. See the right hand illustration. This situation creates a telephoto effect as it makes everything look zoomed in. So the lens should be equal to the inches of the sensor to fully make use of the sensor. Hello guys again. Now we're gonna talk about some technologies. So the first technology is DNR, Dynamic Noise Reduction. This technology preserves all the important forensic detail you need, while lowering bandwidth and storage requirements. And the average percentage of this reduction is different between each brand to another brand. For example, for AKS, this technology is called Zipstream, and the average of reduction is more than 50%. At Bosch, this technology is called IDNR, and the average is more than 30%. At Sony brand, it's called XDNR. At Honeywell, 3DNR, and 3D noise filtering at Pelco, and others. Next, we have wide dynamic range. So, WDR mode is a technology that extends the camera's range to cover greater span between the bright and the dark area in the image. Typically, the camera will produce an image where objects in the dark area will hardly be visible. So, wide dynamic range solves this by applying techniques such as using different exposure for different objects in a scene to enable objects in both bright and dark area to be visible. For better performance in low light condition, the automatic exposure automatically detects the light level and maintains a clear picture if this mode is activated. The other technology is auto tracking. This technology is dedicated for PTZ camera. It automatically detects, zoom in, and follow moving objects. This facilitates live monitoring by helping the operator to effectively discover and handle incidents. And this technology of intelligent defog automatically detects fog in the scene and digitally filters it out of view to provide clearer video. And for video motion detection is included on most of camera and encoders. It adds intelligence to your video surveillance solution by sending alerts when it detects motion from moving objects, such as person or vehicles, within predefined areas. The application also reduces storage and bandwidth as camera only record when there is movement. Next technology is darkness totally visible. This technology have different name at different brand. For example, it calls Starlight at Bosch, or Lightfinder at AKS, or Stellar at Aricont, or Survision at Pelco, or Darkfighter at Hikvision, or others. This technology can provide color image in little looks light. Next is the hybrid mode. So the camera have two output video, one from RJ45 for the IP signal and second is BNC for the analog signal. This enables the camera to operate in hybrid mode. Did you hear about video analysis? These days, a massive amount of video is being recorded, but never watched or reviewed, due to lack of time. As a result, events and activities are missed, and suspicious behavior is not noticed in the time to prevent incidents. This has led to the development of intelligent video. Intelligent video compromises any solution where the video surveillance system automatically performs analysis of the captured video. Application range from analytics such as video motion detection and audio detection to more advanced systems including camera tampering detection, people counting, virtual fences, and vehicle license plates. Bandwidth influences is the most important information to know because the main influencer of the amount of storage required for recording is the bandwidth. The higher the bandwidth, the more storage space is required to store video, so the more expensive solution is, because more storage means more hardware to buy. So the bandwidth is influenced by video resolution, video compression type, image per second, scenery, number of camera, continuous recording or event-based, and some technology like DNR. Don't worry guys, we'll see all these variables step by step in the next lecture. Let's try by the video resolution. Standard resolution is the horizontal number of pixels multiplied by the vertical number of pixels on the image sensor. For example, the HD resolution has 1280 by 720 pixels, then a total pixel count is 921,600. So the resolution of the video influences the bandwidth in a simple way. A higher resolution means a higher pixel, so that means a higher stream. And finally, a higher stream means a higher bandwidth. As an FYI, you can modify the full stream of the camera resolution by a lower one to optimize the storage recording. And the video compression is reduction of data for reducing the transmission bandwidth. And we have three standard codecs are commonly used for surveillance: MJPEG as frame-based encoding, MPEG-4 and H.264 as sequence-based encoding, and there is also some least common standard as MXPEG, JPEG 2000 and MPEG-2. So the frame-based encoding codec like MJPEG or Motion JPEG consists of sequence of full JPEG images that have been individually compressed. The example below show 5 frames per second set of 640 multiplied by 480 images. Each image is 60 kilobytes, which generates 300 kilobytes of data per second. And for a sequence-based encoding codec like MPEG-4 or H.264 or H.265 start with a full reference frame called iframe or keyframe, used when generating the subsequent frames. And the subsequent frame consists of only pixels that changed, and that's what we call p-frame. It predicts the content based on the previous frame, as you can see here from the example. As a result, this group of pictures called GOP starts with the full reference frame called iframe, and the p-frame show only what changed from the previous frame. Let's take a look here at some trade-off and consideration when choosing a codec. In order to compress the data, the CPU needs to do more work, and as a result, storage and bandwidth are reduced. As you can see here from the example, H.264 need more processor than Motion JPEG, but the other way, they do more compression, and as a result, H.264 produce a very lower bandwidth, more than 75% lower than Motion JPEG, and that means least storage needed. The image per second, or what we call IPS, influences the bandwidth. A higher IPS means a shorter group of picture, and that produce a higher bandwidth. It's 2 megabit per second in our example, as you can see. And a lower IPS means a longer gap, and that produce a lower bandwidth. And it's just 500 kilobit in our example. And you have to know that the scenario or field of view of the camera can impact the bandwidth in the following way. The more activity on the scene, the higher the bandwidth. In this example, there is a big difference between a full stadium and fairly abandoned parking. And also the number of camera has an impact on the bandwidth of the system. So the more camera on your system generally means a higher system bandwidth. For example here, if we have two camera, we will have 4 megabit per second as a bandwidth, but if we have 6 camera, we will have 12 megabit per second. And for recording mode, the continuous recording does not have an effect on the retention time of the video, but purely indicates that the camera should always be recording and that there is no special trigger needed to start the recording. But the alarm-based recording only records on specific events like motion detection or perimeter detection or other type of alarm. It's triggered by pre-configured alarm. And we have also some technology that reduce bandwidth that I explained on the previous slides. For example, we have DNR, dynamic noise reduction, or AE, auto exposure. Thank you for your watching and see you on the next lecture. Welcome back everybody. And for the rotation time, we can record video for an infinite amount of days, depending on the available storage. But this is not necessary, means isn't allowed. In generally, the majority of countries, the retention time of recording vary from 7 to 30 days, following the installation rules are HE2 and APSAT. For example, in France, the rules for recording are limited to 30 days. And for the Netherlands, you are not allowed to store video for more than 28 days without explicit consent of the government. And now let's move to the storage types. We will classify storage into the following types: direct attached storage, storage area network, and indirect attached storage. So for the direct attached storage is recommended to ensure a reliable connection and high write speeds, resulting in high video database integrity. And for the storage area network or SAN are mostly exceeded through the network using connection technologies such as iSCSI. iSCSI means Internet Small Computer System Interface. It's a virtual SCSI connection, which is attached to the recording server with a fiber optic data link. And the other classification of storage is indirect attached storage. It could be NAS, network attached storage, or DAS as USB drivers. These storage technology are typically larger in total volume and resemble file server. Indirect storage devices are also less responsive than direct attached. Indirect attached storage can consist of any combination of hard disk and added redundancy measures. In video security, the risk of losing recorded video could lead to serious problems. That's why we use RAID. So the RAID is extremely useful if you require reliability and data redundancy. And also it allows to survive a disk loss without data loss. Without RAID, you have no form of redundancy. Let's move now to the RAID storage techniques. RAID means redundant array of independent disks. It rates several hard disks as one logic unit in order to increase data redundancy and performance. Some key terms to understand when we're talking about RAID are stripping, mirroring, and parity. For the data stripping is the spreading of sequential and random blocks of data over multiple disks. For the data mirroring involves writing the same data to multiple disks, and parity utilize stripping and checksum methods and calculate for the data blocks. Don't worry guys, we'll see exactly how each RAID use those methods, so let's move now to the RAID types. Let's start by RAID 0. RAID 0 involves stripping data across several disks, 2 at minimum. It is faster. Its drawback is that it is less secure even than the other types, because the data is spread in chunks across multiple disks, and we risk losing all the data if one disk becomes corrupted, since if we lose even a part of the data, we are unable to reconstruct the original. That's why we have no redundancy, and this is not used for any critical system. The total storage capacity that we can use is the total of all hard drive capacity, as long as they have the same capacity. In the case of different capacity, the total storage could be used is the capacity of the smallest hard drive multiplied by the number of hard drive. For example, if you have in this example disk 1 is 500 GB and the disk 2 is 1 TB, we can only use 500 GB at disk 1, and the same for the disk 2. We can only use 500 GB at disk 2. So the total storage could be used in the system using RAID 0 is 1 TB. So next we have RAID 1. For RAID 1 involves mirroring data on more than one disk. This adds a level of redundancy to the data, making it more secure, but also more expensive. Since all data is duplicated, it essentially cuts the available disk space in half, making the cost per megabit of the data higher. RAID 1 requires a minimum of 2 disks. If one hard drive failed, crashed, burned, or whatever, we still read the data normally, and we will not have any issue on the performance, because the data are already copied on another hard drive. The total storage could be used is 50%. RAID 5 is more advanced technology. It generates a parity bit per strip for added security. Parity bits are used as the simple form of error detection code. In the case of disk failure for RAID 5 system, the lost data can be replicated on replacement disks. Please remember, at RAID 5 we can reconstruct data if only one hard drive failed. If more than one hard drive crashed, unfortunately we cannot rebuild data. In RAID 5, 3 disk minimum required, and 1 disk capacity is dedicated for the parity, so the total storage could be used is the total storage capacity less than 1 disk. Before we continue, let's see how well you remember terms related to RAID storage. Take 1 minute to choose the blue boxes below into the corresponding yellow box at the right. So the correct answer for the spreading of sequential and random blocks of the data over multiple disks is stripping. The correct answer is data stripping. And for the writing of the same data to multiple disks is mirroring. So the correct answer is data mirroring. And for writing to disks as the simplest form of error detection code is parity bit. So the correct answer is parity bit. And the same thing in this exercise too. Take 1 minute to choose the blue boxes below into the corresponding yellow boxes at the right. So for stripping no mirroring mean RAID 0. And for mirroring but no stripping is RAID 1. And for single disk parity bit is RAID 5. Welcome back everybody. So first I want to talk a bit about the importance of system design and some key components to consider. Let's start by why system design. So you have to know that determining the right specifications is a critical part of designing a surveillance project. Our goal is to ensure that the video surveillance system always performs to the customer's expectation and function in a stable manner. So no images or recording are lost. We also have to make sure hardware will not be a bottleneck for achieving our surveillance objective. So for that, we have to respect some certification and regulation of video security system, such as national regulation, company regulation, and also some standard for video security system. Of course, cost is also an important matter for the customer. So we have to find the optimal balance between price and performance. Let's move now to the best design module for video security system. This module is step-by-step guide and checklist for each case step in the design process. Let me introduce you to the module. So first of all, we start by defining surveillance objectives. In this first element, we have to identify our goals for the installation. What surveillance issues are you trying to solve? What are the major pain points? And determine all scenarios and physical location for surveillance. And after that, we have to perform a full survey of the installation site. For that, we do site survey. That means doing a visit on site to identify and document the number of camera, placement, distance to the object, and field of view. And also determine what challenges exist in regard to physical condition like mounting, lighting, cabling, power, and environmental issues. Also, know what kind of detection does the end user like to have, and consider what each camera will be used for: identification, recognition, general surveillance, etc. Next, we move to determine image quality and features. So, we have to determine the camera requirements based on defined objective and site survey. Each camera should assist in meeting an objective. For that, we have to determine camera placement, resolution, focal length, technology, features and accessories to use. For example, pole mount, wall mount, or corner mount, or PoE injector, or other accessories. The perfect way to make things easy is to place cameras with similar functions into groups to make the system design easy to manage. Next, we have to identify workstation and display. That means identify the number and location of client workstations. So we have to determine how many monitors each workstation will have, and the maximum number of cameras that will be viewed at each workstation, just to determine exactly the performance of the workstation and the future of the graphic cards. Next, we have to identify the case system requirements. So we have to identify the basic system capabilities and how to deploy and manage the system. For example, multi or site-side deployment, Active Directory or not, remote or mobile access, centralized system management or not. And after that, we have to select product. At this point, you have identified all equipments should be used in your video security system. I recommend using for the camera their own product selector to select the product that meet that required functionality. Also the same thing for the VMS to make sure the required numbers of camera, server and workstation are supported. So let's take a look for the product selector of some brand of camera. First, let's say we have a tender done by an engineer consultant, or you already did a site survey and we need the cameras with these specifications. A fixed outdoor camera rated for protection against impact and vandal acts, that means IK10. We need 2 megapixel minimum as resolution. The focal length should be variable between 5 and 10 mm, and it should have also these technologies: 120 decibel for WDR, DNR, PoE, and some technologies light finder or starlight or any equivalent. So let's start by choosing Axis camera comply with these specifications. First, enter to www.axis.com, click on Learning and Support, choose Product Selector, and here you can see all the variable specifications that you can choose. For the type, we choose fixed camera, OK for outdoor ready. The resolution is 2 megapixel. The vandal rating is IK10, OK for light finder. And for WDR, all the Axis camera are 120 decibel. So just we let it as not specified. And for the zip stream as a variable of DNR, we choose zip stream. So as you can see here, we have multiple choices. So let's do a comparative between them. So here, as you can see, we have different resolution. Let's start by the cheapest one, the 2 megapixel. So all the specifications are all comply. We have just to verify the focal length. As you can see, the focal length is complete with our specifications because 5 until 10 mm is included on the focal length of the camera, 4.4 to 10 mm. So the perfect choices for our project is AKS Q1635E. Let's move now to see how to choose the complete camera with Bosch brand. First, enter to www.videoselector.boschsecurity.com and click on IP camera. The product category is IP camera. For the product type, we choose fixed IP camera. The resolution is 2 megapixel, that means 1080p. OK for outdoor ready. OK for wide dynamic range. OK for IDNR, that means intelligent dynamic noise. OK for starlight. It should be varifocal. The vendor resistant, we have to choose IK10. And as you can see, we have only one choice. So let's see and verify the focal length. As you can see, the focal length is complete with our specifications because 5 to 10 mm is included on the focal length of the camera, 2.8 to 12 mm. Next, we have to specify the network topology and calculate the bandwidth. Network topology plays a critical role in surveillance system because video stream creates a lot of network traffic. To avoid conflicts with other network traffic from our customers' business, we generally recommend separating the cameras from the business network. So in this part, you have to specify the stream bandwidth for cameras. Generally, you can have this bandwidth information from the calcul notes done by the VMS calculator, or if you want to be more specific, you can use the stream in camera datasheet or at the constructor website. Next, we move to specify server and storage recommendation. In this part, you have to use the VMS server calculator to obtain a hardware specification. Evaluate whether the specification meets the customer's requirement and budget. If necessary, reevaluate the design choices and return the hardware specification calculation. For that, you have to know the recording and live resolution, frame per second, continuous recording, or on motion detection, which type of decompression used. After that, we create proposal. At this point, you can calculate the hardware labor pricing and deliver proposal to your customer. So to calculate the bill of material with the price, you have to use your Rustler or integrator price list, or even the MSRP if you are an end user and you want to budget your solution. MSRP means public price. You can have this price list from your distributor if you are an integrator or an installer, or from the constructor directly if you are a distributor. For some brand and work policy, you have to send a request for quote to the distributor for any project, and the price changes depending on the size of the project and the competition in the market. So if the proposal was accepted and the project is won, the customer may have additional needs, or you may suggest various improvements to the solution. You need to reevaluate the design objectives and rectify the network and the hardware specification to incorporate those changes before proceeding to outline the installation details. And after that, you have to define the system and operator behavior. This is for big installation where the roles are too much important for the different users. So in this part, you have to define roles and permission for each type or group of users. Determine specific systems and operator behaviors the customer requires. For example, what camera could each type of group view in live? who needs to be notified when the communication with devices is lost, and other rules. And finally, you have to document the work and create statement of work. So the statement of work sets the customer's expectation in writing with specific details on how the project will be installed. So any work requested by the customers beyond what is documented in the statement of work is a change order and additional billable work.